Okay, so welcome back, and we're going to do some other examples of eliminating the parameter. And so we'll start with part A. A has the setup that we have x of t is equal to the square root of t, 2t plus 4. And then we've got y of t is equal to 2t plus 1. And we're restricting the parameter from -2 to 6. Okay, so what we're going to do is we're going to eliminate the parameter, and we'll get this in terms of x and y. Okay, so now what I'm going to do here is I'm going to eliminate t, so I'm going to solve for t in this one. So I'm going to square both sides. So again, this is going to be x equals the square root of 2t plus 4. Okay, and so I'm going to square both sides, so I get x squared equals 2t plus 4. And then I'm going to subtract 4 and divide by 2. So I get t equals x squared minus 4 over 2. Now notice in this case, x is always non-negative, right? Because x is squared. Okay? So x is non-negative. So now what we're going to do is we're going to plug t into here. So we're going to plug this value for t into this equation, so we get y equals 2t plus 1, which then equals 2 times what? X squared minus 4 over 2 plus 1. And so if we simplify this, the 2's cancel, and we get y equals x squared minus 3. And so what do we get? Well, now we've got an equation of a parabola. So we've got y is a function of x, and it's quadratic. So we've got a parabola that opens upward. Now notice that this is restricted by t, right? So what happens here when t is -2 and when t is 6? Well, we got to figure out what the domain of this thing is, right? What's the domain? Well, the domain here is restricted by the parameter t. So to get the corresponding domain in terms of x, we're going to have to plug in the endpoints, right? See what's going on here. So if we plug in -2 here, right? So x of -2 gives us what? Well, 0, right? And if we put in x of 6, what does that give us? Well, that gives us 16, right? Square root of 16, which is 4, right? Okay? And so our domain then is for x on the interval from 0 to 4. Okay? And then of course then we can graph this and see what it looks like. Okay? And again, when you graph this, you want to make sure you put the orientation in there, right? Because again, this is based on the parameter t, and so it's going from -2 to 6, but also recognize that on the x-axis, it's going to go from 0 to 4 on the x-axis, okay? And that's it for that one. Okay, so now let's look at part B, okay? So now part B has this setup. So we have x of t is equal to 4 cosine t, and we have y of t is equal to 3 sine t, and t is between 0 and 2 pi. Now, in this case here, sometimes we have to be a little bit creative when we're trying to eliminate t, the parameter t, okay? So in the last two examples I did, it was just basically solving for one variable, solving for t in one of the variables, and then just substituting it for the other equation, the other parametric equation. Okay? So, but in this case, it's not straightforward of how we're going to do that. Okay? So, well, we've got to be able to relate x and y somehow. Okay? So, so here's the thing. Solving either one of these by t directly is not really going to work. It's not advisable because then sine and cosine are not one-to-one functions. Okay? So let me repeat that. These are not one-to-one functions. So you can't solve for t directly. Okay? Now, however, dividing the first equation by 4 and the second equation by 3 and suppressing the t gives us some equations that we might be able to work with. So if I look at this, and let's rewrite this in terms of the trig function. So let's write this. X is equal to 4 cosine t. So that tells us that cosine t is equal to x over 4. And here we got y equals 3 sine t. And so we could write sine t is equal to y over 3, right? Okay, now, okay, this is where the creativity comes in. Because at this point, one of the identities we could use is the Pythagorean identity. Okay, so we know, right, that, well, it doesn't matter, but let me just write it. So we get sine squared t plus cosine squared t equals 1. We know that, right? That's a fact. So now all we have to do is replace sine and cosine with what we have here. So what do we get? Let me erase up here so I can write higher on the board. So what do I get? If I just substitute in, now what do I get? I get 4 over, oops, not 4. I get y over 3 quantity squared plus x over 4 quantity squared is equal to 1. Okay? And so now if I simplify this, I get what? Y squared over 9 plus x squared over 16 equals 1. And so now immediately you should recognize that this is the equation of an ellipse. Okay? It's a horizontal ellipse centered at the origin, with the semi-major axis 4 and the semi-minor axis 3, right? So remember the A and B, right? So this is y squared over A plus x squared over B equals 1. Or excuse me, I'm sorry. Yeah. This should be A squared. Okay. So A gives you the semi-minor, right? And the semi-major. Again, remember 2A is the or actually, nope, I got this backwards, because A should be the major axis. So the larger number. Okay, but the point is that we have an ellipse. Okay, so this is an ellipse. It's a horizontal ellipse because the major axis is with the x, so it's along the x-axis. It's centered at the origin because we have, remember, the general form is y minus h, or excuse me, x minus h and y minus k. Okay, so it's always center hk, just like a circle, right? So there's that. So we know what it looks like. Okay, and again, remember the different aspects of an ellipse. Okay, especially if you need to graph it, right? So then, again, the restriction, right? So t progresses from 0 to 2 pi, right? And so this goes in a counterclockwise. Okay, so we're going from 0 to 2 pi. And so at 0, right, so again, so we want to see what this thing behaves. And remember, it's t goes from 0 to 2 pi. Okay, and remember x, the formula for the equation for x was 4 cosine t. Okay, and so if we draw okay, and so since this is the major axis, so we know it goes out 4 units this way, so this is going to be here, and it goes out 4 units this way, so it's going to be here, and then on the minor axis it's 3 units down and 3 units up. Okay. And so if we sketch the graph, we know it's going to look something like this. Oops. Something like that. Okay. Now, where the directional lines come in is the fact that we start at 0, right? And so when t is equal to 0, x is 4, right? So it starts right here. So it's going to start right here, and it's going to go counterclockwise. Now, when t is 2 pi, we're right back to 4. Okay, positive 4, x is positive 4. So basically x is going this way, and then it's coming back, right? So we get this trace that goes all the way around and ends up right back where it started. Okay? So this would be equal to t equal to 0. Obviously this is t equal to pi over 2. This is going to be t equal to pi. This is t equal to 3 pi over 2. And then of course we're right back to t equals 2 pi, which is the same as t equal to 0. Okay, so now here's one for you guys. Okay. So eliminate the parameter for the plane curve defined by the following parametric equations and describe the resulting graph. So here's one for you guys to work on. Okay, try that one and we will continue on. We'll look at doing some more examples. See you next time.